Hello, we are discussing about GATE 2005 ECE paper. Look at the open loop system given with unity feedback. For this one, indicate the correct root locus diagram. Okay. As we know, root locus diagram is going to be consisting of root locus branches. Each branch originates, that is starts at open loop pole and ends at either open loop 0, that is finite open loop 0, or a 0 at infinity. Okay, so first of all first step in the root locus plot is you have to plot the open loop zeros and open loop poles on the S plane. Okay, then identifying the root locus branches, then you are going to draw the root locus plot. So first step is indicating the open loop poles and zeros on the S plane. So this is S plane, so it is sigma and it is j omega. This is called as S plane. Okay, so zeros are going to be related to numerator, poles are related to the denominator. So only one zero present in the numerator, because it has only 1 minus s term. So s is equal to 1. At 1 there is a 0. And next, poles are related to denominator, and one pole is at origin, the other pole is at minus 3. So one pole is at origin, the other pole is at minus 3. Now if you observe, there are 4 branches are going to be present. One is, okay, right of this one is first branch, and between the branch between 0 and 1, and this is third branch, and it is fourth branch. So out of these 4 branches, which will be treated as root locus branches? Root locus branch is going to be traversal of, it's going to be a traversal of closed loop poles. So for system stability, closed loop poles must be present on left half of S plane. So we can find the root locus branches only by considering left half of S plane. Simply we will ignore right half of S plane, poles as well as zeros. Okay, while calculating root locus branch on negative real axis, we will use the poles present on negative real axis only. We should ignore the poles as well as zeros present on positive real axis, that is nothing but right hand side S plane. The poles and zeros present on right hand side S plane should be neglected. So these 2 branches we are not interested. Okay, and now if you are going to check whether this third branch is a part of root locus or not, for that one simply you have to indicate a point. Okay, you must consider a point, and right of this point, that is nothing but right side of this point, if algebraic sum of total open loop poles and zeros are going to be odd, then that point is going to be a part of root locus branch. But while you are going to sum poles and zeros, you must consider those which are present on negative real axis, and you should neglect they present if they present on positive real axis. So you are going to neglect this 0 while going to calculate the root locus branch condition. So only one pole is present, so right of this point is going to be having odd number of sum of algebraic sum of open loop poles and zeros. So this will be a root locus branch. And we know root locus branch originates from the open loop poles, so like this. And this will not be the root locus branch, because if you take any point right of this minus 3, left of this minus 3, then algebraic sum is going to be even. 2 poles will be present, so only odd number will give the root locus branch. Now they must end up at either finite 0, otherwise a 0 at infinite. So they are going to break like this. And one is going this side and the other is going this side. Since there is a 0 present at 1, okay, it will be going in this way and it is reaching a point. It is reaching a point over here. This is going to be called as break away point. Break away point, and this point is going to be called as break in point. Break in point, and after that it will be going in this way and the branch is going to be coming in this side. So this is going to be a root locus plot. So the right plot for this root locus is going to be, answer is C. C is the right answer for this one.